A warm welcome to one and all. Today let's discuss about resource recovery from solid waste, composting and biomethanization. Myself Dr. V. Garvin Sharmila, Associate Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. First of all, let's see about what is composting. Composting is nothing that biological method of managing the waste in order to get useful byproduct, that is the compost. So we know the biodegradation is a natural process, is a biological process. It will occur both for the human made as well as the natural environment. So this organic material which are exist in the natural societies usually decomposed by means of biological method and will generate the byproducts such as compost. So this compost has been utilized for the manure in the agricultural area. So the compost is the end product of composting. So and the remaining byproduct obtained along with the compost is carbon dioxide, water, and also it may generate heat as well as the odor too. So compost is like which is humus, dark in color and or have a bad odor, that is like a earthy odor which is like that of the resemble like that of topsoil. So this compost is highly beneficial for agricultural purpose and it is devoid of seeds or organism and pathogen and the pathogenic nature of the compost is also highly reduced. So this compost has the number of benefits which can be utilized as the has economic attractive advantages which can be utilized as a fertilizer in the fertilizer. So nearly this composting has been generated highly in the part of India. 75% of waste which was generated in India is majorly of organic waste. So by following the process of composting, most of the waste can be reduced as in the form of compost and can be utilized as a fertilizer which helps in the reduction of the soil erosion, ecological balance, and it may provide a higher beneficial nutrient to the environment. So types of composting, the types of composting are the windrow composting, static pile composting as well as in vessel composting. So in the windrows composting, the composting process is usually done in a set of longer rows so that the sludge of waste has been usually aerated by the convection air supply or the convection method of diffusing the air into the waste mixture so that the waste has been oxidized aerobically and it will get reduced in the form of compost. So these windrow techniques are highly implemented and also it is a most commonly utilized approachable method of composting process. It was least expensive. So these windrows are usually defined as the regularly turned elongated piles and has each haystack of cross section which is about 100 meter or more in length. So the cross sectional dimension usually varies. So and the turning process is continuously done in order to efficient composting of the waste material. Most of the municipal solid waste in the windrows are 1.5 to 3 meter high and are usually located on the impermeable surfaces and it depends upon the process efficiency depends upon the weather condition and also the process can be controlled through proper management of the turning of these waste periodically in order to expose the complete oxygen supply to the organic matter to get decomposed. Next is static pile. In the static pile method, the continuous aeration has been provided by means of the mechanical aerator technique. So this pile has a network system of pipe which are connected to the blower so that the air supply was provided to the waste biomasses continuously without any delay. The air that can be supplied by means of positive as well as the negative pressure in this session. Forcing the air may generate the positive pressure system, while expelling the air from those system of organic waste is termed as to be the negative pressure. So the compost is taken once the air is passed into the organic biomass, the waste get degraded and form a compost. These composts are removed continuously and it was utilized for the manure purpose. So through this process the optimum temperature has to be maintained. Hence, in order to maintain this optimum temperature, the excess heat and the water vapor has been or alternatively provided to maintain the optimum temperature. So the controlled air supply within the pile of the static composting process, the land necessary for the degradation of the organic matter can be reduced, and also the bad odor expulsion was prevented, so that the filters also provided to control the proper management of air outlet. Hence this type of method of aerating static piles has been set up for organic matter degradation, and the compost will be generated for every 6 to 12 weeks. Then in-vessel composting. In this in-vessel composting, the feedstock has been placed in a chamber on vessels, and the adequate mixing or aeration or moisturization has been done periodically. So the drum, digester bin, tunnels are some of the common in-vessel type of system. So in this in-vessel type of system, there will be a single or multi-compartment, and it is stationary and it is kept in a stationary setup or in by mixing or agitating mechanism, and it was moved continuously around the material. So all of the vessels that is exist in this in-vessel composting system undergo the composting process, and the materials are obtained or finally discharged into the environment. So the major advantages of this in-vessel system is the environmental conditions have been controlled and properly monitored for that may allow that enhances. So the proper monitoring of this environmental condition, the composting process was occurred in a rapid manner, and also the frequency of turning in the in-vessel composting is higher than compared to other type of composting, so that there will be a homogenized form of mixture can be obtained as a compost, which may promotes the continuous tanning may helps in the proper providence of air supply within the waste products, thereby promoting the rapid oxygen transfer. So the maximum duration for the organic matter degradation to form compost is about only to 1 week, or it may take to 4 weeks. So this type of composting is usually happened in a horizontal, vertical as well as in the horizontal manner based on the method of supply of air. These are all the operation steps involved in the composting process. First, initially, the non-compostable substance, that is the inorganic material in the form of plastic, glasses, papers are removed initially. Then those materials that is left up for composting process was grinded and shredded. This grinding and shredding process is usually carried out in order to maintain the uniformity or the homogeneity among the particles that was disposed in the form of solid waste, so that the proper decomposition of those waste in the pile or the bin or the digestion can occur. After the grinding and shredding, bleaching or proportioning of materials. This is used to mainly focus to improve the bacterial or the microbial degradation process. So the hydrogen and the nitrogen and the carbon nitrogen ratio has to be maintained in between 30 to 35:1. So the blending process is considered to be necessary until the carbon and the nitrogen ratio reaches 30 to 35 is to 1. If the carbon nitrogen ratio was 25 to 30 is to 1 means it is unnecessary to induce the blending process, so that the optimum moisture content that is required for the aerobic composting is must be within 40 to 60 percentage. After that, placement for composting. Here initially the waste has been placed on the ground or on the windrows or in the shallow pit in order, and the piles has been provided which is not greater than 1.5 meter to 1.8 meter and it not less than 1.07 meter to 1.7 meter, so that the open pile through this open pile the air has been provided and it is get diffused into the solid waste for composting. After that the process of composting take place. So the width at the bottom of the windrows is about 2.44 meter to 3.6 meter. Now let's see about factors in composting operation. So the factors in the composting operation, usually the turning, temperature. The turning is the one of the major factor which determines the efficiency of the composting operation, since the aerobic condition is the major process which was enhanced due to the frequent turning operations. So the frequent turning is necessary and the turning is the major factor to determine the efficiency of the composting and the quality of the compost which are obtained at the final stage of composting process. So if the moisture content is high means it requires high amount of turning for every 2 to 3 days. So and also as such the of turning, temperature is also an important factor which determines the composting operation. So the temperature range must be 50 to 70 degrees Celsius and usually 600 degrees Celsius is satisfactory. The temperature higher than 710, that is the excessive temperature of 710 degrees Celsius is very injurious for the bacterial action. So in order to control the excessive temperature, the height of the static piles or the windows must be lowered, so that lowering of this method can improve the temperature maintenance and also the optimize the temperature. If the temperature drops, the condition will become an anaerobic process, then it will causes the anaerobic degradation and will generate the expulsion of the gases, bioenergy in the form of biogas. So to avoid those process and to enhance the composting substances, proper tanning and the temperature maintenance is necessary. Then and some various other factors which determine the composting process operations are segregation of refuses and salvages, grinding, shredding, carbon nitrogen ratio maintenance, blending of the waste which was generated, and the moisture content maintenance, and also the placement of material properly in the composting pit or the windrows, and to maintain the temperature. Proper aeration should be provided to reduce the excess moisture content in the composting material. Then in addition to that, the organism which was involved in the process of composting is an important factor which determines the efficiency of the process. The inoculum which we are provided is also an important factor. The reaction that occurs within the process of composting, climatic condition, the pathogenic organism destruction, and the time of composting operation, as well as the fly controls. These are all the factors which involved in the proper management of the composting process. In addition to this, above all factor, the maintenance of proper nutrient and the nitrogen ratio is very important. After the final stages of composting, we receive the compost as the byproduct. The compost must be tested in a proper way so that it can be utilized for the natural manure, and as well in terms of economic concern, this final product composting is consist of the organic matters which was in the form of decayed stages. So this was become the one of the best fertilizer in the present scenario. Uses and constraints. So while considering the uses, the compost is one of the best material which improves the soil moisture retention, because it was provided. Compost is highly obtained due to the process of aerobic degradation. So the existence of the moisture content is high in the composting process. Hence, it is considered to be a good soil conditioner, and it also based on the composition and the source of the waste. The compost obtained may varies, and it can be utilized as a soil amendment for the agricultural soil as well as the municipal park. So, two important purposes for composting the organic substances are necessary are first is reclamation or conversion of the nutrient and fertilizer, and sanitary treatment and the disposal of waste to prevent the diseases. So the compost which you are obtained is usually brown in color, and the properties of these compost are light in weight and are lightly sandy like that of the topsoil, and it can hold the water for the more number of duration, and enlarging the root system of the plant by since it is a manure. Next method of biological degradation of the waste biomasses that was disposed in the form of municipal waste is biomethanation process. The biomethanation is nothing, it is a process of biological degradation of the organic substances under controlled condition and temperature, pH, moisture, to evolve the methane as well as the carbon dioxide. So this is the most technically a viable operation which was highly implemented in the municipal solid waste management, since this process utilizes the high rich organic and the moisture content waste biomass as a source of substrate. So usually the biogas production which was obtained from the waste biomass is about 50 to 150 meter cube per ton. So the composition, based on the composition of the waste, the efficiency of the generation of the biogas varies. The biogas obtained from this method of anaerobic digestion can be utilized for cooking as well as the heating process, and it can also be utilized as a fuel for engine, gas engines, steam turbines can be processed to generate electricity. So the final sludge which was obtained from the anaerobic digestion can be used as a soil conditioner, which is same as that of the compost which is obtained from during the process of composting. These are all the stages of biomethanation process. Usually the biomethanation can be divided into three stages. In the first stages, the fermentative bacteria, that is mainly the anaerobic or the facultative microorganism, divides the complex material, that is the carbohydrate, protein, lipid, into the fatty acid, alcohol, carbon dioxide, hydrogen, ammonia and sulfate, and then this obtained monomers has been utilized by the acetogenic bacteria in the second stages and produces the hydrogen and carbon dioxide and acetic acid. At the third stages, methanogenic bacteria first utilizes the carbon dioxide that was evolved and then reduce it into the methane and the acetic acid to the methane and carbon dioxide, which may enhances the generation of biogas. So the flow chart gives the each and every stages of the biomethanation process. But first, the hydrolysis occurs. Here the particulate organic matter, carbohydrate, protein, lipid reduced to amino acid, sugar, alcohol. In the acidogenesis, acidogenesis is the intermediate process which is between the acidogenic as well as the hydrolysis process, in which the intermediate products such as volatile acid, ethanol, propane, acetate, lactate is formed. From that, the acidogens consume those alcohols and the volatile fatty acid generate acetate and hydrogen and carbon dioxide. This was utilized by the methanogenic bacteria, which leads to the generation of the biogas. Some of the application of the biogas which was generated during the process of biomethanation is The biogas can be utilized as a fuel, and this fuel source can be utilized for the generation of the electricity and to run the mechanical power, etc. And the humus which was obtained, or the sludge which was digested, which was left over after the biomethanation process, has rich in fertilizer ability and can reduces the water as well as the air pollution. Thank you.